is equal to this expression, right? And so let's work through this expression by adding in these known values. And when we do that, this simplifies to an equation you might have seen before. The temperature in Celsius is equal to 5/9 of the temperature in Fahrenheit minus 32. Right? Very simple equation. Now let's try to code up this equation in C. Okay. So we write a program that converts from Fahrenheit to Celsius. Again, here's our expanded out formula. We want to write our code with all of these constants in this case. We're not going to use the simplified version. We want it to be a little more general. So let's say you wanted to convert to Kelvin instead of Celsius. You could do that by changing some of these constants. And so let's step through this program. So again, we start with our main function. We define these constants. In this case, we're using a set of variables so that we can write out the names of these quantities. So we have freezing point in Celsius, freezing in Fahrenheit, boil in Celsius, boil in Fahrenheit, right? And then we'll have a set of doubles that are our temperature, our input temperature in Fahrenheit, and our output in Celsius. So we ask the user for the Fahrenheit temperature. We have our scanf with our %LF because we're taking in a double. And then we calculate our temperature in Celsius. So this is a direct translation of this equation, as you'll see. We're taking in these variables that we've defined and putting them right into the equation. And then we print out the result. And that's the program. So it turns out that there's an error in this program. And this error has to do with this temperature calculation. So I'm going to ask you guys to take a minute to talk to each other and try to figure out which operation causes the error. So the A is assigned to the minus, B is the division, C is the minus, D is the multiplication, and E is that plus. If you guys haven't done so, get your answers in the next 10 seconds.
Is it somewhere in int? Like that's int, and then I guess I would convert it to a double. Then you first time taking? Yeah. Okay.
Let's take a look at what you guys thought. So most of you thought it was B, the division. Some of you, a good portion of you thought it might be the multiplication. And that's really good intuition, right? Because you're going to have most of your problems, if you'll note, the functions that we're defining, we gave them integer variable types, right? And we're doing a double computation. And so that was really good intuition that a lot of your trouble would be at both multiplication and division. But it turns out that the division was the big problem here, right? And let's take a look at why that was the case. So it turns out that we have a bug here, which is we end up getting an integer division that truncates to 0. And if you take a look at the equation, if we go back a slide, we had this 5/9, right? That was the result of that division. And since we're using whole integer types, this 5/9 calculation would go to 0. And so that would be the first big problem in this. That would be the big problem in this equation. So let's look at a couple of ways we could have corrected this problem. So the first option for correction is pretty straightforward. We could have used doubles instead of ints, right? So the key here would be to define all of these values as doubles, and then this operation would go just fine, right? So there's a reason why we might not want to use this solution, right? Or why this solution might not be applicable. So it's fine in this small piece of code, but if you're writing a much larger program, let's say with a lot more constants that you're defining, or a lot more inputs to the program, you might not want to use the double type, because remember it uses twice as much memory. So instead, we can go with another correction option, and that is to use typecasting. And so we could have retained our integer type, but instead, we could have casted when we did our calculation. This is also more computationally efficient as well, because it turns out that doing operations with doubles is more expensive than operations with integers on most computers. And so if you're doing a lot of processing, you want to use your computation efficiently. So for example, these subtractions, we might want them to happen as integer math. But then by casting this first expression in the parens as a double, we force the division into a double operation. Right? And so that way we're conserving the number of operations and creating a more efficient program.
So had you had parentheses around the whole division operation, then it still would have just did integer division.
So that is a really good question, which is if we had a set of parentheses that extended from here all the way to here,
Yeah.
we'd still have the error because the quantity within those parentheses would still be interpreted as being full integer types,
Okay.
and so we'd still get a 0.
Is there a way to put parentheses with parentheses inside them? Because you have parentheses around the boil of Celsius minus that. Is there a way to put parentheses around that without it being cut off after the freezing of Celsius?
Sorry, so you want parentheses around this whole division?
Yes.
Yeah, so one thing I will say, those parentheses aren't necessary in this equation, but oftentimes putting in extra parentheses can help with readability, right? Because you know what the order of operations are, but if you have a complex equation, you might want to see it spelled out with parentheses. So here what you could do is you could put the parentheses outside of this double and extend it all the way out here. So that would ensure that this first quantity got upgraded to a double, and then the second quantity got up.
Yeah, but how would you type that? Because usually if you just, well, at least for me, if you put parentheses at the beginning, open parentheses, close parentheses right after double would end that parenthesis.
Yeah, you can put in another parentheses in front of this parenthesis, so you can have two parentheses.
Yeah, but the first closed parentheses would end.
It would only end the most innermost parentheses.
Okay.
Is that good?
Yeah.
Great. So yeah, I mean, the compiler is counting open parentheses and then closing them sequentially.
Okay.
So I wanted to introduce some additional operators. And these are useful abbreviations, right, that you can write into your code to make it more compact and more readable. So it turns out that oftentimes we write expressions of this form, where we're taking a variable x, and we're setting it equal to itself plus some additional value, or minus, or multiply. And this turns out to be a very common expression. And so it turns out there's a shorthand for doing that, and that's x plus equals y, right? So this expression is equivalent to this longer expression. And this works for all arithmetic operators. So for x equals x plus 1, then x plus y, we just showed you that form. But you can do this for subtraction as well, multiplication, division, even modulo. So all of these can be interpreted in an expanded out form. And it turns out these also work for what are called logic expressions, which you haven't seen yet, but you'll see in the next one. So another type of abbreviation is something called unary increment and decrement. So you saw a shorthand form for adding a value to a variable. But it turns out that it's very common to increase or decrease a variable by 1. Right? You'll end up doing this a lot in your code as we introduce some further syntax and options in C. So there's an even shorter abbreviation for this, because obviously you could have written this as x plus equals 1, but you can also do this by writing x plus plus or plus plus x. Similarly, you can write out x minus minus or minus minus x. And so these will increment x by 1, these will decrement x by 1. So why are there two forms? Why is there this x plus plus and this plus plus x? So there's a little bit of subtlety here. And so just hang on for a moment. So x plus plus increments x after the expression is evaluated. Right? So to see what that looks like, let's say you wrote some syntax like this, right? You got a function, and you're calling it with x plus plus. Well, the compiler actually interprets this as calling the function with x, and then incrementing x. So when you call the function x, it's not getting x plus 1 as 0, it's getting x. But when this line of code is finished, it'll actually increment the x value. Plus plus x increments x before the expression is evaluated. And so things look a little differently. So if you call the function with plus plus x, we first increment x, and then we call f with that just freshly incremented. So as an example, let's say we set x equals 5, and let's take a look at what the values of x, y, and z will be. So obviously when we set x equal to 5, it's equal to 5. We don't know what y is because I haven't shown you the earlier piece of code. And we similarly don't know what z is yet. If we call y equals plus plus x, in this line of, when this line of code is finished, obviously we will increment x, but we'll also set y equal to 6, right? And you see why that is? It's because we're incrementing x before we're doing the assignment. And we still don't know what z is, but in this next line, right, we're setting z equal to x plus plus. So what does x look like after we run this line of code? Well, we've incremented x, so it goes up to 7. Y is still set to 6, right, because we haven't done anything to y. Any guesses as to what z would be? So I see we have a few different options here, so I'm going to take a poll. If you think z is equal to 5, select A. If you think it's equal to 6, select B. If you think it's equal to 7, select C. And if you think none of those are correct, select D. See, I have some E responses. So it looks like we're about evenly split between B and C, which are 6 and 7. Okay, so let's explain this. Let me explain this. So it turns out that Z will be set to 6, which is B, which most of you answered. But I can see why there's a little bit of confusion, right? So the thing to focus on is this order of operations, right? So when we have plus plus x, we're saying increment x and then do your assignment. Whereas when we have x plus plus, we're saying assign and then increment x. So since when we started this line of code, x was set to 6, right? So we're saying, okay, do the assignment. So z equals 6, then increment x. Okay? We'll see a few more examples of this later in the lecture. And if you're still confused, talk to me afterwards. So associated with all of this is precedence. We associate with the table. So this is, you're probably all familiar with precedence from just math classes you've taken in the past. And again, the precedence rules are very similar to what you've seen in math before. But since we've defined some operators that are new, we need to look at what precedence would be for all of these operators. So obviously parentheses get the highest precedence. Then we have the unary operators, which also include casting. And then we have multiplication and division, addition and subtraction, and finally assignment, including these special assignment operators, the shorthand. And remember that the associative for parentheses and your basic operations are going left to right. But for these, for assignment and these here operators, we go right to left. So let's take a look at an example. So suppose that we have z, a value z that's initially set to 9. And then we run this piece of code. So we need to use precedence to figure out what's going on in this operation. So obviously we're going to execute the parens first, so that 2 plus 7 is a 9. But then we execute the unary operator, right? So this unary operator, z plus plus, is run next. But since the plus plus is following the z, we're saying increment after you calculate the expression. Right? And the expression here would be this multiplication, right? So we're holding off on incrementing. So z will still be equal to 9 right now. And then next we would do the multiplication. So 9 times 5, we get 45. We've completed this expression, so we're going to increment z. So z goes up to 10 now. If we do the division, 45 divided by 9, 5 for this entire expression. And then finally, we start doing the additions. 4 plus 5, 9. And we add 10, because z got up, incremented. So this entire right side of the equation is 19. Now we go from right to left to do our assignment. Y gets set to 19, and then x gets set to 19. Is that pretty clear? So, get your clickers ready. We're going to go through a few examples to see where all we're at. So, for all of these examples, we're going to have a set of variables. They're all doubles, y and x. And let's take a look at what x and y would be after this line of code is. And pretend there's a semicolon here. So in this case, I'm going to start writing responses now. take a minute and talk to each other. And you can edit your answers. Focus down on C and D as different options, right? So I can see why you have the confusion with this increment, but remember how you interpret this plus plus that follows variable. It means that the increment happens after, right? We run this expression. So what that means is that for this plus equals, it sees y as 2, right? So what we have is x plus equals 2. So the correct answer here would be C, right? Would be 3.
So the plus plus would only apply if you gave another variable equals y. For example, if you after that you put z equals y,
yeah, so
z would be 4.
It's after the expression is evaluated. So y plus plus is in this expression. So what we're saying is hold off on evaluate this expression, and then when you're done evaluating, then
So it never comes out.
it'll happen after.
So if you called X again after you did that, would it be 4? So basically, like right now, you did your expression. It's sitting there. It's sitting at 3, and if you were to call X, you would actually see 4 instead of 3, or
Because what happens, if hold on to that thought,
Okay.
it'll get a little clearer. Okay, so I think you guys are doing pretty well with this one. Most of you answered C. Which is correct. Because here, once this line of code is complete, we'll increment y. So let's look at another example. Assume that this line of code was not run, that we're starting afresh, that we've declared our variables, and then we run this line of code. Great, I think you guys have got that down. So the answer is B, or 4. And just to compare these two lines of code, right, here again we're incrementing before we apply this plus equals. Whereas here we're applying the plus equals and then incrementing, right? Then y gets involved. Does that make things a little clearer?
so basically it goes is X plus Y first. We don't see the the y changed to a 3.
Yeah, in this first example, that's a good way of putting it. The plus equals hasn't seen y get incremented yet.
Okay.
So that expression evaluates. And then y gets incremented.
So-
Whereas down here, this expression sees the y get incremented. So we now have y equal to 3 before we apply the plus equals.
Okay.
If you had plus y on the end of the top one, if you add that to the end of the expression, plus y,
Yep.
would the
So-
y be treated as a 3 or a 2?
So try that out in your compiler. So that's actually a pretty tricky example. So just in general, when you have these plus plus operators on a variable, if you include that variable in the same line of code, what the compiler does is kind of tricky. And so I generally don't suggest it or test it pretty thoroughly because there's essentially what it's doing is it's going to evaluate the expressions in the order of operations, and it'll increment as soon as it finishes the operation, right? So in that example, it's a little complicated because this plus equals gets applied once you finish figuring out what's on the right-hand side.
Yeah.
So that's where it gets a little complicated. So let's move on to another question here. Okay. Great. I see most of you are seeing that we're going to get the same value for y, right? Again, it gets incremented. Let's look at a couple more examples. So zy and x are getting assigned, again, the same values. And so here's that trickier example you're talking about. Great. You see that most of you correctly answered that. Awesome. So we can unpack this a little bit. This one's a pretty complicated one. So what happens is we need to go by our order of operations, right? So in our order of operations, we're going to apply this multiplication. Well, first we apply the unary operator. So the first thing that's going to happen is this expression is going to get evaluated. So if we look into this expression, we apply the unary operator, which says, okay, we're going to eventually increment y, but let's hold off until we're done with the expressions. So we start with y equals 2, so 2 times z, which is 5. So this gets calculated out to be 10. Then we increment. So that's going to increment y up by 1. So now y is equal to 3. But then it gets incremented again. So it gets incremented to 4. So we get 10 plus 4. Then we apply this final expression where we're adding 10 plus 4 to x, and we get 15.
You said y got incremented to equal 3, and then you're going to increment it again. Why do you get incremented twice?
Because notice that there's 2 plus pluses in here. So what's going to happen, again, to review that example, this would be like the last example for today, is that this unary operator is saying, hold off on incrementing, run this expression, run this multiplication. So we get 2 times 5. This quantity is 10. Then we increment y. So now y is equal to 3. We need to do this addition, but before we do this addition, because the plus plus is before the y, we need to increment y again. So y goes to 4. before the addition.
So there's a whole other set of plus plus y, you have to increment again, you know, pi.
Yeah, so if the plus plus is after, then it would get delayed. Sorry, why is